Today we'll be covering Persistent Volume Chain, PVC, Jupyter Lab, and we used Nucleo Serverless Function and other services on the Iguazio platform to build an end-to-end data pipeline for the simulation of network failure detection. Here is a demonstration starting with Iguazio compute components running on a Kubernetes cluster.
The compute components run on a Kubernetes cluster. We deploy, by default, our deployment has our managed version of the Kubernetes cluster, but you can also deploy on AWS EKS for scalability, or Iguazio works with customers to deploy on existing Kubernetes clusters as well. So once I have Cloud Manager with, first of all, the knowledge of my Kubernetes cluster and the config that gives it the credentials to be able to deploy Trident, I can now define the volume. And once Trident is installed, then all I have to do is in the Iguazio cluster, the Kubernetes cluster that is running Iguazio, define that persistent volume claim, which is a standard Kubernetes procedure. So in this case, this is I already have the storage class that the Cloud Manager generated. All I have to do is define that persistent volume claim, and in my cluster, this is actually called basic. So this is I have to run this against the Iguazio Kubernetes cluster. Once I have this in place, I have the ability to access that volume from multiple places within the cluster, both managed services as well as jobs that run in the cluster. And I'll show you how that connection happens. So if I were to deploy a Jupyter notebook that needs access to that cloud volume, and for the purpose of the demo, I'm going to edit my own Jupyter notebook. As you go through definition of the Jupyter notebook, in which you can both limit CPU and memory, so this developer does not exceed a certain amount of memory. Typically, this is a 16 gig limit. Since in Iguazio, you have the ability to deploy jobs to run outside of the Jupyter notebook environment, you can lower the limit on the notebooks and let the developers deploy jobs that require more resources but do not run within the Jupyter notebook environment. If I had GPUs in this cluster, I should be able to also allocate a GPU if it was required for this Jupyter notebook. And then I have the ability to define a persistent volume claim that will be mounted on that Jupyter notebook. So this is the persistent volume claim that I defined based on that Trident cloud volume that was defined previously, and is going to mount on the /NetApp directory in my Jupyter notebook. So what that looks like once I'm working on my Jupyter notebook, if I cd2/NetApp in my Jupyter notebook, this is giving me access to that volume. And as if it was mounted, it is actually mounted on my notebook, and I can write code and refer to that path, working within this notebook environment. But I also, if I know it's mounted on /NetApp, as I build jobs that will be executed outside of the notebook environment, I can actually make that mount the same, and I'll show you that as we go through the demo, so that way I don't have to change paths as things get executed. Now, for the purpose of this demo, we're going to leverage snapshots, NetApp snapshots for that cloud volume. The purpose of that is to freeze, to create a version, of data set that we're going to use for training. And we're going to create a snapshot of that directory that has all the metrics that are constantly being fed into our demo. And and then run the training based on that snapshot of that volume. So that way we can keep a version of the data that we use for training. So if the snapshot directory is available also within the Jupyter notebook, so I can see the snapshots that I created as I practice and as I develop this demo. So now we have all the components that we need to have access to large amounts of data that reside on NetApp, be able to take a snapshot of that data so we can do the training and have a record of the data sets that we use to do that training. And we can leverage the power of Iguazio to do the training and the deployment of that model. And now I'm going to take you through the process of what a developer will do in the Iguazio environment to be able to build all the steps that ultimately will become a pipeline that you can run and will provide inferencing on data that is coming in to give you real-time feedback of what's going on with that data. The example, the use case that we're working with is network operations. So this is machine data, machine that is coming in from network devices. It is based on a current customer of Iguazio. This use case is used by that customer to detect issues with network equipment and proactively take action on any possible failure to prevent that from affecting the customer. So that's the goal of this implementation, is to predict network failures and avoid customer impact. So as a developer starts working with the environment, the first thing is to do data ingestion. Now, for the purpose of this demo, what we have done is we created a serverless function that runs every 10 minutes. This is leveraging our serverless environment, serverless functions framework called Nucleo, and it is simulating the incoming data from network devices. So this is just to do simulation of data consumption. This has information about a company, data center, the device, and then we provide metrics about CPU utilization. Let me find out what that is. CPU utilization, latency, packet loss, throughput. All this information is being generated automatically. It is running as a function as a serverless function in our framework. It consumes resources when it comes up, and then it reduces the consumption as it stops running. And this is just because we're leveraging the power of Kubernetes to be able to do that type of work and not consume resources. Now, one other thing that I want to point out, and I should have pointed out in the beginning, is for the developer working in Iguazio and interacting with Jupyter notebooks, they see no difference than if we're working with Jupyter on any other platform. The key thing is that, first of all, this is integrated with our security. So it's role-based access control. So if I try to access somebody else's notebook, I will be prompted for a user and a password. So going back to this is Jupyter. Any user used to Jupyter notebooks will be familiar with this interface. This is controlled by role-based access control, so I cannot access somebody else's notebook. My directory with my information and things that I'm working on is mounted on my notebook, and I also have access to other locations within our framework, as well as access to the NetApp folder where all the big data is residing. So going back to the demo, I have data generator. So the first step as a data scientist is to do the data prep.